So guys, actually I'm trying to talk about a new topic called as joints. Okay, this joints can be, what do you mean by joint here? Particularly think that. So when I'm trying to talk about joints, assembly of components. See, joints are mainly used to assemble the components. There are basically two types, which you know it. Already we have seen one of such joint. We call as welded joints. This is a permanent joint. Why it is called as a permanent joint? Because if you want to dismantle the components which has been joined, what exactly happens in case of welded joints, you need to break the component. That is the reason why we call it as permanent joints. Okay, but in case of temporary joints, see, we have already done something called as couplings. Coupling is a temporary joint. Okay, we have done one in couplings, one in welded joints. Couplings is a kind of a temporary joint where if you want to dismantle it, the base parts will never get affected. That is what exactly the difference between temporary joints and permanent. Similarly, like couplings, we have some joints called as knuckle and quarter joints. Now the question comes: when do I use couplings and when do I use knuckle and quarter joints? Okay. Now these are the different terms which are available in the industries. They call it as couplings. Couplings, you have seen it. Couplings are mainly used to join the shafts. Guys. The shafts which are rotating. Keep that in mind. Couplings are used for the shafts which are rotating at very high speeds. So couplings are mainly used to transmit the torque. That is where exactly I'll be trying to use the couplings. Now then the question comes, when do I use knuckle joints? Can you tell me guys, have you ever seen a joint in a bicycle chain? Have you seen this bicycle chain, right? Hello? So if you can observe this bicycle chain, try to understand. The bicycle chain has so many links. This kind of joint. Okay, I'll talk about this kind of knuckle joint or quarter joint. So which are not rotating, non-rotating shafts. Okay, try to understand this. Whenever there are non-rotating shafts, then I'll be making use of this knuckle joints or quarter joints. So that is what exactly. Let me share the screen also. This one to you. Can you see this notes, right? Hello.
Yes, sir.
Right.
Yes, sir.
Now. So let me write this concept joints. Okay. As I was trying to do is, we have seen two types of joints. You have already seen one. On the other side, you have seen couplings. Okay, and you have seen welded joints. That is what we have studied. There are many joints, but I am writing the joints which we have studied this. Okay. Now these couplings are maybe used to connect two rotating shafts. Okay, it can be axial. It can be not compulsory that it should be this one axial, or small misalignment can also be there. Now here welded joints, especially when I talk about this welded joints, the shaft, it is normally anything. It is a permanent process. Permanent, we call this as welded as a permanent joint. Now the question comes: these are called as temporary joints. Yes. These are the temporary joints. Okay, temporary joints means can be easily removed. Here the two base metals cannot be removed. Now the question comes: there is one more joint, one of the temporary joint called as knuckle joint. Okay, knuckle joint, and I'll be trying to talk about and something called as quarter joint. These are the two joints which are there in our syllabus also, and you can see this most frequently in the industries also. You have something called as a knuckle joint, you have something called as a quarter joint. Okay, let me talk initially about knuckle joints, then I'll be trying to talk about the quarter joints. Now here, couplings, I have already told you, couplings are used to connect two rotating shafts. Then when do I use, or indirectly I can say that this couplings, when I say rotating shafts transmit which force? They transmit torque. But always every connected joints will not transmit torque. There will be not only rotating shaft. Let me say for example, if you see this bicycle chain, let me say for example, okay, chain I want to observe is I'll be having a joint here. There is a link. Okay, and there will be one more link here which is connected to this. There will be one more link which will be connected in this case. Now, can anyone tell me what kind of force when I pedal a bicycle, what kind of force this link is subjected to? Can anyone tell me now? Just tell me. I'm drawing a bicycle chain, a link kind of chain. What kind of force this link will have when I pedal it? Anyone, guys? So I have a bicycle chain. There will be a link here. What kind of force it has? It is subjected to. What kind of force it is subjected to, guys?
Axial, sir.
Right, axial, tensile forces. So axial load, axial tensile force. This is what exactly it is subjected to, guys. What you said is true. Okay. Now what exactly happens in this case? Sorry. Right. So once again, as you see on the screen, it is axial tensile force. So what you said is true. Okay, it is the axial force. When I pedal it, obviously there will be axial force in this case. Now the joint which you see in this case, is an example of knuckle joint. So now can you tell me why knuckle joints are used? They are used to connect two rods or two elements that transmit axial tensile force. Keep that in mind. So are used to connect two rods or two elements, anything that transmit axial tensile force. So that is what exactly we call as knuckle joint does. Okay, are used to connect two rods elements that transmit axial tensile force. Now that is a basic difference between couplings when I am trying to talk about this couplings, and when here I try to talk about knuckle joints. Knuckle joints are used to connect, the couplings are used to connect between two rods that transmit torque. To transmit torque, compulsorily it should be rotating. That is the reason why I said it is rotating shafts. But in this case, it should connect between two elements that are subjected to axial force. Axial force as the best example, as you see in this case of bicycle chains. Okay. Now here, what happens is this axis, the axis of the two elements can coincide or obviously can intersect in the same plane, or small misalignment can also happen. Let me say, for example, there is two rods, which I mean to say here, the two rods, the axis of the two rods can be same at the same plane. Let me say there is one axis, the other axis is here. This is the other axis. So the two axes can be in a straight line, or sometimes the two axes can be something like this. Slightly it will be inclined. That also it works. But only one thing is it should coincide at one point. So here it should, if I extend this, okay, if I extend this, it should coincide at one point. That is a major basic thing. So the in two intersecting shafts. The other thing is when I say two rods, the basic condition is the rods or the axis of the rods must intersect. The axis of rods must intersect. That is a basic thing. So only one thing is it should be able to, either it can be in straight line or it can be any angle. Only one thing, it cannot do with parallel shafts. When the rods are parallel, when the axes are parallel, I cannot use knuckle joint. But the basic thing, let me say parallel, I cannot use knuckle joint. But if the two axes are trying to coincide at any point, so obviously yes, I can use knuckle joint. So what does it mean is knuckle joints will allow limited angular moment. So some angular moment it is going to allow between the two rods. That is what exactly we call as knuckle joints. Now where are these applications, guys? I'll be trying to talk about the applications of knuckle joints. You can see this in suspension bridges. Suspension bridges, you can see it, or bicycle chain, which I have already seen. Bicycle chain, you can say it, or in wall mechanism of a reciprocating engines. So So all these points will be having this knuckle joint. So only one disadvantage is it cannot transmit torque. Keep that in mind. It cannot be used to transmit torque. Cannot be used. So I'll be writing it. So these are the different things. So cannot be used. Be used to transmit torque. So try to see, guys, now what exactly is knuckle joint. Knuckle joint, so let me once again review this knuckle joint to you guys. Knuckle joint, these are the joints which are used to connect two rods or two elements that transmit axial force. The basic condition is the axis of the rods must intersect. The axis of the rods must intersect. So either in case 1 or case 2, okay, in this third case, it cannot work. It must intersect. So it has got many applications. It cannot be used to transmit torque. Best example, it has got suspension bridges, bicycle chains, wall mechanisms, so many things. Okay, it has got other names. The knuckle joint, sometimes in some industries, they are also called as forked pin joint. So the other name of knuckle joint is also called as forked pin joint. This is what exactly I'll be trying to talk about in today's class. I'll be trying to talk about knuckle joint. So let me share the PPT to you guys. So here, so these are the joints. So practically, how does this joint looks? It is not only a cycle chain, guys. Okay, the joint has different shapes. Okay, one of the famous this one which you can see. Now try to see. I have already explained this temporary. What is temporary joints and what are the different temporary joints? This is a kind of knuckle joint and quarter joint which you see on the screen. Left hand side you see something called as a knuckle joint. On the right hand side you see something called as a quarter joint. Now left hand side can try to see this. There are few elements on the left hand side. Okay, if you can observe here, let me say there is this part which we see on the screen. We call this as a rod. Okay, can you see this? This is kind of a rod. Now our shaft. This is the shaft which is connected now. This is the long shaft which is connected. Now there is one more shaft here. I can say that it can be shaft or rod. Okay. Now see this. The end of the shaft is in shape as a fork. Now let me say this is the first one. Let me say I call this as fork. The first element which you see on the screen is called as a fork. So there is a shaft, very long shaft. Try to see here, very long shaft. But they have missioned in such a way that the long shaft has been missioned in such a way that at one end, when it is coming at one end, there is something called as a fork. See the shape. So this shape, what you see in the green color, is called as a fork. So the shaft has been designed itself in the form of a fork. The other side, this is the second one. I call this the second element of this. So second element we call it as I, E-Y-E-I. The second element we call it as I. Okay. Now this I, so there is a second rod. This is a second rod. So there is a rod here. Once again, the rod is there. There is one axis, but this is the other rod. So here I have two rods. The second rod is been shaped in the form of a I. So second rod is shaped in the form of I. Now there is a third element which you see on this, the violet color one, or bottom the pink color one. Okay. The third one we call this as the nut or pin. We call this as a pin. So basically it has three components. The first one is called as a fork. Second one is called as an eye, and third one we call it as a pin. Now here the point which you need to understand in this case is the first one, when I say fork, pin and eye, it is not connected, mounted on the shafts. Now you remember in case of knuckle couplings, the couplings are mounted. It has certain hole. Coupling has some hole. The entire coupling is mounted on the shaft by using a keyway. But in this case, when I ask the difference, what is the difference between the construction of knuckle joint and couplings? The end of the rod, the end of the shaft itself is made as a fork. It is not mounted. The shaft itself is designed like a fork here. That is what the knuckle joint. Okay, the shaft itself is designed as a fork, or one of the shaft is designed the end of the shaft will be looking like a eye. Okay, and this fork and eye will be joined. Okay, I will try to see this now parts. So we call this as a fork. Okay, first one we call this as fork. Second one is called as a eye. Third one is a knuckle pin. So these are the three components which you do. So additional to lock it, we use a pin. Okay, to lock this, we use a pin here. So these are the components of a knuckle joint. So any questions in the knuckle joint? Any questions? Can you recall what exactly we have done once again? So knuckle joint, how many parts we have in knuckle joint, guys? Knuckle joint basically has three components. Okay. Now, first component we call as a fork, second component is called as a knuckle eye, and third component is called as a knuckle pen. Okay. And now, so quarter I will talk about this later. Now, try to see how this comes in chapter number 17 of your data handbook. So, in chapter number 17, you have this diagram. In chapter number 17, the diagram is here. Okay, this entire view of this diagram. Okay. How do we work on this, or we are going to design this? Before designing, two things which you need to understand is what are the different dimensions is most important. Design means finding out dimensions, finding out the dimensions. Let us understand. Come back to my screen notes. So let me start. What are the different parts of knuckle joint? So the different parts of knuckle joint, we have three parts. One is we call it as a fork. First one we call this as fork. Second one we call this as eye, and third one we call this as pin. Okay, these are the three parts of a knuckle joint. So let me draw this, if at all, the same diagram which you see on the screen now. Okay, which you see on the screen. Okay, so one, I have fork here, I have a pin, we have a pin. We have seen three-dimensional, and sorry, this is eye, and this is called as a pin. This is called as a pin. So what I will be trying to do is I will be trying to disassemble it, and I will be trying to draw it with the dimensions. If possible, you also draw. Okay, if you are having the notebook, you can also parallelly draw with me. So try to see here. I have a shaft here. The shaft. This is the shaft. The shaft is very long shaft. So what we'll be trying to do is the shaft is designed in such a way that the end of the shaft, I'll keep it in such a way that this slowly turns into the shape of a fork. The shaft will be converted into the shape of a fork. So once again, this is the shape of the fork. So this is the shaft. Okay, you have a shaft here. Okay, this is the shaft which you have. Now here, this part, there will be a small hole which will be created. There will be a hole. If you cut it, you can see a hole here. There will be a hole here. So that what happens, I can a hole for connecting the remaining eye and pin. Okay, so there is a hole. This is called as the eye. So let me hash it. Obviously, this is a cross section. Okay, if you see this is a cross section. How it looks if I hash it. There is a cross section inside. You can see the hole also here. So we call this component as the fork. So we call this as fork. Now, so what are the dimensions of fork? So let us understand the dimensions of the fork so that you can remember this. Now the diameter of the shaft, as usual, we call this as D. This is the diameter of the shaft, which I want you to remember. Diameter of the shaft. Now there is one second. As soon as the shaft goes, the diameter of the shaft will be enlarged. Now try to see here this portion. Pi D, I call it as pi D1. Pi D1 is called as the diameter of the enlarged end. I will once again write it. Pi D1. Diameter of enlarged end. D is the diameter of the shaft. D1 is the diameter of the enlarged end. Okay. So these are the two dimensions. At this point of time, we remember it. Then still we'll go ahead. Now let me draw something called as a fork. How this fork we have already drawn. Let me draw something called as eye. Okay, what exactly is this eye? How does it look like? Okay, let me draw this. Okay, now what happens here is, in this case, there is one more shaft at the other side which is coming. There is one more shaft. Okay, there is a shaft. So what this shaft will have, once again, I'll enlarge it. The same thing. Diameter of the shaft is D. So what I'll be trying to do is, we have a kind of a eye. Very simple concept. Okay, there will be I, which will be having a hole. Once again, it has a hole. The diameter of the hole will be equal to the diameter of the pin. Okay, so if you see this cross section, this is how it looks. So this is other shaft, or you can say other rod. So once again, what are the basic dimensions? Now for this also, the basic dimensions are diameter is D. In this case, the diameter is pi D. Okay. Now here, this is the axis to be joined. This is the axis we have. The same axis, the same diameters you can have here. So basically, this is called as an I. Now at the same time, we'll be having one more element. We call this as a pin, guys. We call this as pin. Okay, the pin is placed on this from the top. The pin is placed. I'll be trying to draw this. The pin will have something called as pin head. This is a pin head. Okay, and this is the portion. So this pin will be inserted in the hole. So once again, try to understand how the assembly will happen. So once again, there is a rod on the left hand. We call this as I, E-Y-E. Sorry, I call this as fork, F-O-R-K, because it will be like a fork. It is a fork. Now here we call this as I, fork, I, and I have something called as a pin, P-I-N. So three elements. So fork, inside the fork I will be placed, and this two will be connected by using a pin. So what are the different dimensions we have got here? Okay, try to see this diagram. If you have any doubts at any point of time, please ask me. So one is small d. I have already written the dimensions or notations. I can say that notations. First one is D. D is called as dia of the rod, diameter of the rod. It can be on the left side or it can be on the right side. Diameter, assuming that both the diameters are same. So D is the diameter of the rod. Now D1, dia of enlarged end or enlarged diameter, also we call it as enlarged end. Okay, or so at the rod end. So it is an enlarged diameter, especially in this case, obviously the rod end, especially in case of fork, or it can be in case of I. We call this as D1. Now once you have see D and D1, there is something called as a D2, guys. Here, if you see here on the screen, let me draw the D2 for you. This diameter is called as pi D2. How do I name it, guys? What is the name of the diameter D2? Oh, sorry, not this one. This is D2, pi D2. This is D3. I call this as D3. Now, can you tell me what is D2 now? What is D2? Achyuta or Sneha? What is D2? What do you name D2?
Small, sir.
Diameter of?
Small pin.
Pin. Dia of pin. Dia of pin. And D3 is dia of pinhead. Dia of pinhead. Okay, even see when you am writing the notes here, I am expecting you so that you also are writing parallelly, so that I have given some time for you to do it. Else, if it is in PPT, what was happening is I need to go very fast. So that is the reason why I am trying to write it in the form of notes, so that you can understand and you can also write parallelly with me. So this is diameter D3. So we have a diameter. Once again, D3. I'll write it. So I have got diameter D3. So you have got diameter D. D is nothing but diameter of the rod. D1 is the diameter of the enlarged end. D2 is the diameter of the pin. D3 is the diameter of the pin head. Now let us see what is D4. Now this is D4. We have pi D4. So D4 is called as diameter of the I of the fork. Now here, this one. Dia of your I. Okay, dia of the I. We call this as D4. Now, what are the other dimensions which we'll be trying to say is the other dimensions is H. This is H. Now, in this case, the H, what we call it as H. So h is the thickness of the pinhead. Thickness of pinhead, we call this as h. Then there are certain dimensions, we call this as dimension A. This is A. Now A is called as thickness of fork. Thickness of fork, and we have something called as a B. So eighth one, there is something called as a B. This is called as a B. This is called as a B. So once again, I call this B as thickness of I. So these are the dimensions. What are the dimensions we have now? Let me repeat. If it is for the rod, if it is the rod, I'm going to design the rod as two dimensions. I have a rod. One is D and D1. Try to see this, how exactly I go for design. There are two diameters which I'll be trying to find for the rod. One is D and one is D1. D is called as diameter of the rod and D1 is called as enlarged diameter of the rod. Enlarged diameter of the rod. Now, next one, I'll be trying to design the fork. We'll be trying to design the fork. What are the dimensions I have for the fork? For the fork, you have a few dimensions, like you have, if you can see here. So you have A for the fork, you have A for the fork, you have, as well as D. Can you see this? The D4. If you see this D4, the diameter of the D4 is same as here. This part also is D4. This also will be D4 itself. I can say that D4 is nothing but diameter of the eye or diameter of the fork. Anything will be okay. Diameter of the eye or diameter of the fork, if you observe. So once again, I can say that for A and D4 I have. In case of eye, okay, since D4 I have already found, there is only one dimension for the eye, it is B. Only B I need to find. Now once again, after finding eye, there is something called as a pin. The diameter, so for the pin, what does I have? I have got D2, D3 and H. So once you find these dimensions, your design is done. So basically, these are the parts of the knuckle joint. These are the notations which you need to find. These are the dimensions which you need to find. Any questions till now? Anything you would like to ask me now?